Dear participants, this particular experiment is based on experiment number 10 and 11 of section 2 IAVOC 105 practical coursework. Definitely this part of the coursework is pertinent to the electrical theory paper that you are having. You can see here we are having in front of us a three-phase induction motor. This is a specially made motor, half HP motor, three-phase, and the terminals are kept open only for the demonstration purpose. Okay, you can find as you know as per the theory, the three-phase induction motor has got three windings. Okay, so these windings are having the terminals like this. You can see this is red, these two are the red terminals, these two are the blue terminals, and these two are the yellow terminals. As per the standard nomenclature, this is U1 and U2. You can find here U1 and U2. This is V1 and V2, and this is W1 and W2. Okay, this particular orientation of the terminals has got a particular reason, because we would like to connect the motor either in star configuration or in delta configuration. Here we will be connecting the motor in these two configurations, and we will see the voltage that will appear across the phase, and in each case we will be measured the current that is flowing through the phase. All right, as we know, in star configuration both the values of voltage and current they are less, and therefore during starting of an induction motor normally star configuration is maintained for some time, so that initial high surge of current cannot damage the windings of the motor. After that, the motor is automatically shifted to the delta configuration or delta connection. Here we will not be going for an automatic changeover. The changeover we will do manually. However, in your next semester you will be coming across automatic changeover circuit that you have to design by yourself. So first we will be connecting the motor in star configuration. Another thing that we should know, that we are feeding the motor through an auto transformer, where we are trying to maintain a 220 volt phase to neutral supply. So now let us see that how we are going to make the star connection. You know that the star connection can be of 3-wire type and 4-wire type. Here we will be using a 4-wire connection, where the 3 phase lines will be coming from the auto transformer output, and there will be a neutral connection as well. Star connection is very easy. You will have to short this terminal, this terminal, and this terminal. Kindly corroborate this with the star diagram. You can easily find that one end of each of the phases are connected at a common terminal. So that we will do here. You can see I have shorted these two terminals, and again I have shorted these two terminals. Actually, when we are doing it, we for some with some standard operation we have got shorts particularly meant for this purpose. However, since we are here doing makeshift connections, we are using jumper wires. However, during performance of the practical we should remember that there are open terminals of these jumper wires, therefore we should be very careful while performing the experiment. And definitely that I am time and again telling you, while performing practicals with electrical you should be very careful, and there is no allowance for any horseplay. Now what we will do, these are the three connections. These are the connections that we have taken from the auto transformer. This blue terminal I will connect here. The yellow terminal I will connect here. And the red terminal I will connect here. Now we will also connect a voltmeter. Here we are interested in seeing that what is the voltage per phase. That means what is the voltage across one phase, what is the voltage across another phase, like that. For which I will be connecting the voltmeter. You can see one is the common terminal, other is the measuring terminal. One terminal will be connected to the neutral terminal and this will be connected to one of the phases. So here we will be able to measure the phase voltage. Alright. So now we will put the motor on. You can see this is a brake drum arrangement and that's where you can see the shaft of the motor. When the motor starts, this particular brake drum arrangement will start rotating and you can see. At the same time you will be finding a humming sound that itself says that the motor has been started. Oh, sorry. Just put it up. I forgot to give the neutral connection. The neutral has to be given since this is a 4-wire connection. Extremely sorry. And here you find the neutral. So here you can find the neutral connection which is common. Now you can see the motor has started rotating. You can see here the rotation you can find. Now it is very important that we should understand what is the phase voltage. You can see here the voltage across one of the phases is 228 volt. Now I will very carefully remove this terminal. Although I never suggest that you do it by yourself, you should put it off and do. You can see same sort of voltage you are seeing. And if you measure voltage across two phases, that is 400 volt. Now we will be interested in seeing the current. What is the phase current? I will be using a tongue tester for that. This is a clamp meter you can find. We are already very familiar with this device. So I will connect it like this. And you can see here the phase current is around 0.16 ampere for blue phase. For yellow phase, it is again around 0.18 ampere, like that. I solemnly suggest that you kindly note down the readings. The phase voltage is around 220 volt, that is phase to neutral voltage, that is voltage that is appearing across one phase, and the phase current is 0.18 ampere. Now we will wait for a while and we will connect the motor in delta configuration. Remember that in delta configuration we have no neutral connection. So I will be removing first all the connections and then I will be connecting the motor in delta configuration. Delta configuration is also very easy. There is nothing to be very worried about. However, while doing the connection, we must understand why we are doing the same. You can find here that this U1, that is, this is terminal of one of the windings and this is another terminal of another winding. Okay, so what we will do, since the delta says us that one end of one terminal should be connected to another end of another terminal. Now you see this V2 is here, this V2 is here and V1 is here. So now we can very easily connect this V1 and W2. Now you can find this W2 is here, W2 is here and W1 is here. So we can very simply short. This becomes your delta connection. You have to do nothing else. Now here, as we had already discussed earlier, we need no neutral connection. Now I will be simply connecting the output of the auto transformer to the three phases. And here you can find that we have no phase to neutral voltage measurement because we have to measure our voltage across the phases only. So here we will be measuring the voltage across V1 phase and W1 phase, V1 and W1 terminal. That is one of the phases that we will be measuring. Okay, or this is V1 and W1, so we will be measuring across two phases. We need to measure across single phase, that is V1 and V2, that we will measure here. Now you can see what is the voltage across one phase, that is V1 and V2. They actually correspond to the two terminals of a single phase. So that we will see right now first, and then we will go for measurement of current. Now you can see the motor has started. Now you kindly go through the voltage. Earlier we had measured the voltage across a single terminal, a single phase, that was from one terminal of the phase to neutral. Now again you can find we are measuring the voltage across one phase only, but now the voltage is 400 volt. And let us now try to measure phase current. I will do it for red phase. Here you can see the red phase is having current of 0.67 ampere. Kindly note down this value. For yellow phase, again we will find this 0.79 ampere. And for blue phase, you can find 0.73 ampere. The summary of the experiment is, in case of star winding, you could find the voltage and current both were less. But in this case, that is in delta winding, the voltage and current both are high. This is the particular essence that you should take out of this experiment. For any of your queries, please do it in the comment box. Thank you.